and welcome. This is Jon Bloom, and today we're going to be talking about Troubleshooting Ninja. So let's get started. As we all know, we live in a perfect world where everything's perfect and nothing ever goes wrong. Or maybe not. So, for many of us in the IT field, the typical work week starts out on Monday where we introduce a bug into production. And on Tuesday, the user reports the bug. On Wednesday, we receive a ticket in the ticketing system that there's a new bug. And on Thursday, we diagnose the bug and reproduce it and apply a fix. On Friday, we deploy the bug fix and all is well. And on Monday, we start out with another bug by introducing another bug. So perhaps that's familiar to some of you. So things don't always work as expected. And when things go wrong, there's certain things you can do. The first one, I would recommend to update your resume. And the second one, perhaps to call a support line for a particular product or vendor in which you are working. And the third thing, I would troubleshoot. So when we troubleshoot, we look online for possibly a documented solution. The other option is to find your own solution. So when we call the support desk, we typically speak with someone at the front line whose job is to gather some information. They're not going to solve your problems. They want to know, who are you, what is the issue, and we'll get back to you. And perhaps send you a ticket with a confirmation in which somebody will work on eventually. We also have the option of looking for the solution ourselves, typically through Google or Bing search. And perhaps we have an error message from the particular software that we're working with, and they'll say, you'll type in, what is this error message? And you'll type it in Google, and chances are you'll get page after page of error message where somebody's documented the problem and perhaps offered a solution. In many cases, the person who documented the issue failed to put sufficient information in the web page for people to diagnose the problem with a conclusion. So typically you'll have to scan through a ton of meaningless comments in the section until you get to the bottom. And typically there's a solution at the bottom, or you may get reference to another page. It takes a lot of effort and it's not going to happen quickly, but there is that option of looking for a documented solution online. And that's the way it works. So typically Google and Bing is our first step in troubleshooting a problem on our own. For example, you come in Monday morning and there's no data in the queue. So what do? You go and you check and you say, SQL agent, job failed. So when that happens, you have to put on your thinking cap and begin your troubleshooting process. There are several steps that you can do, but this is just an example. Another one, I had to install perhaps the Power Pivot plugin for Excel, except our company was international, and attempting to install the plugin in Europe didn't quite work. So I had to do some investigation on the website, and sure enough, there was a post out there somewhere that said you had to do this, and then change it back, and then do this, and then sure enough, it worked. Also, with that same example, you don't just install the Power Pivot plugin. There's like 10 prerequisites that have to be installed on the user's computer. For example, if you're using a 32-bit Office on a 64-bit laptop and your SQL Server is 32-bit, you have to figure out which is the right combination of prerequisites. And that also applies to the MDS plugin. But that's just an example of some of the troubleshooting that you could encounter. So when you figure it out yourself, you're basically floating out at sea with no land in sight, meaning you're on your own. And the boss is paying you to solve the problems. So your job is to solve the problem. So I'll give you an example of something earlier in my career, perhaps around 1999, where our job was to upgrade a particular software vendor, and it didn't work. So the steps involved were to upgrade Oracle from some version to Oracle 8i. And when they did that, it didn't work. And the boss was frantic because we had to deploy the solution sooner than later. So he came to me and said, I know it's not your job responsibility, but we really appreciate if you could solve this problem, because if you don't, we have to bring in the consultants, and they're like $2 something an hour plus hotel plus airfare, and there's no guarantee they're going to solve the problem. So I poked around and I went through the log files, and I figured out that one of the custom tables that wasn't included in the package had a particular field that was, let's say, a varchar 10. And based on the vague error message, I was suggesting that it should perhaps be a 12. Now, I can't just go ahead and make the change, so I had to get with the DBAs to rebuild the table, rerun the install, which it takes a while, and sure enough, it solved the problem. So there you go. That's a good example of troubleshooting in a black box with very limited information, and you just have to use your gut and go with it. Now, working for that same company, we also deployed a help desk application to somewhere on the west coast of the United States, and in doing so, we used Oracle, and I made sure that in the test environment that everything was configured correctly. On go live date, the program went live, and we got a call within 3 minutes that the system was going real slow. So my boss called me in and said, why is it going slow? And I said, I don't know, it should be working fast. So we got on a conference call, and we spoke with the technician out there on the West Coast, and I said, can you please send me the tnsnames.aura file? He said, no. I said, well, could you open it and check that the tnsnames.aura got distributed correctly on all your users' machine? He said, no. So the boss said, go back to your desk and figure it out. So I went back to my desk, and I said, there's no possible way the system is going slow. So I went back to my boss, and I said, I think that the West Coast is still pointing to test. He said, well, go shut the test database. So we went back and shut the test database, and within 3 minutes, we got a call from the West Coast and said the database just went down. So sure enough, my original assumption that the tnsnames.aura file was pointing to test was correct. However, it was a black box environment with no way to troubleshoot whatsoever except on gut. I don't think you're going to find that in any class that you take in the computer science field. So overall, what I'm trying to say is that troubleshooting is not taught in the schools, and you have to figure it out on your own. Sure enough, school does not equal experience. You could take a 4-year class, you could take a 2 years master's, and they're not going to teach you how to troubleshoot. When things work, the textbook knowledge is wonderful. They teach you the proper coding methodologies and syntax, but when things don't go as expected, you have to rely on your troubleshooting skills. You have to expect the unexpected. So always, sometimes, never works, meaning there's always some issue that you hadn't thought about, perhaps a network issue, maybe a hiccup in the network, perhaps the Active Directory, the user got removed, or the service that's running your job perhaps expired. You could have connectivity issues, firewall settings and such, and the most likely culprit is somebody's password expired and nobody was notified and the job just stopped running. So those are some examples of the unexpected. Now, typically as a programmer, we're supposed to trap for errors. And before I got into the data space, I was a programmer. And I remember as a junior programmer meeting with our senior programmer, and he would sit down at the desk and he would drive and he would look through the code line by line, and he would interrogate the code, and he would enforce that we trap for errors. And if we didn't, we would get a lecture. So I was taught early on the importance of looking for the unexpected. And from my experience in the programming world for 20-something years, I've noticed that not everybody traps for errors. They get it to work and they shove it in production. And then all of a sudden, some error occurs, perhaps a divide by zero error or incorrect data format because the value is null or nulls. So you have to trap the errors and you have to handle the errors, And you also have to be able to predict the possible errors ahead of time. When some things go wrong, for example, some places that I like to look are the event logs, because those are useful. They indicate the time and what happened and what the error was, perhaps with some error message where you can go search for it. And a lot of times, for example, in the SSAS Cube world, you may get an error message that means completely nothing to the actual problem. So perhaps that was the final error that was nested up to it bubbled up to the top, but the true error was 10 layers deep. So you really have to investigate. There's upstream errors, perhaps, like maybe the data job was supposed to run, it didn't run, which caused your cube to fail. Other times in the SQL Server world, the temp DB fills up and your disk is full and it just stops working. Also, access denied errors, like we mentioned earlier. So what happens when you find a bug and you find a solution and you're all happy and you go back to your work and you start on your next project? Well, the first thing you should do, perhaps, is to write a blog. That way, for example, you may work on it 2 years later and say, oh, wait a minute, I think I already solved this problem. So you do it for your own benefit. But by blogging, you expose it to the outside world where other people can leverage your knowledge, and that's a good thing. The other thing is, if you have an internal wiki, you might want to post a document there for other programmers. Commenting your code. I mentioned that I used to have sessions with my senior programmer early on in my career, and I was told that we're supposed to comment our code. And if you look at some of the code that's in production today, you may find that there are no comments. And some people do this as job security. They rate the code that is impossible to figure out. So, for example, that same guy, he would say there's 2 ways to write code. One is to find the most intricate, precise code where you could scrunch 100 lines down into 2 lines, and it's great. And you shove it in production and you leave for your next job, and the next guy comes along, he says, what in the heck is this doing? And you've complicated it so much that it's impossible to figure out. And with no comments, you've basically not done a good thing. So I would recommend putting comments in your code so that you can figure it out, as well as the person after you, because somebody's going to have to maintain that code down the road, and you're going to make their lives easier so they don't cuss you out after you're gone. So, as a team player, write legible, concise, meaningful, and accurate comments. Add the date and your name. A lot of times people just add a comment, this does something, and that's it. You don't know when or who. So, you'll also modify the comments over time. And that same programmer told me that you should be able to sit down and read code like a book. And I believe that. So he was a very smart person. And I'm glad I had the opportunity to learn as a junior programmer some of the best practices. Although being in the workforce, you tend to see code that's not the greatest. He also said that 95% of the code that's in production is just crap. So you can take that for what it's worth. So summary, bugs are going to happen. You're not going to find troubleshooting skills in any job description. When you go to apply for a job, how many years of this language do you have? How many years of this? What experience? Tell me about yourself. Has anyone ever asked you about your troubleshooting skills? How do you handle a server that's down and your business is losing $10,000 an hour? How do you perform under stress, under situations that are difficult? Troubleshooting. You're not going to learn it in a textbook. You're not going to learn it from school. It's from rolling up your sleeves and figuring out a problem. Because it can really save you time and possibly your job. So you have to exercise your troubleshooting muscles, and some problems are not documented. This is true. So I would like to say thanks for watching. I hope you learned a few things and found some value in this presentation. And as always, thanks for watching. Bye now.